So we're at home, all of a sudden there's a storm and the trees are blowing and we're staying warm with the heater. Everything is good. Just like that, the power goes out. But the lights are still on and the heater's still going because it kicked into the secondary mode.
Oh yeah.
Well, something I've been working on off and on in the past few months has been to see what it would take to actually power my workshop here off-grid, or at least partially off-grid, and build a system that that can run that very well. And if you would have asked me a few years ago if I would consider using an all-in-one piece of equipment like this guy here, that encapsulates all of those power components into one piece of equipment over, say, taking a more modular approach to that design, I would have definitely opted for the more modular approach. But my tune is changing because these are very capable pieces of equipment now that are all software controlled, configurable, and they really support a lot of different use cases. I envisioned that I would have to be doing some switching between solar and utility power and battery power. I'd have to figure out how to incorporate relays and other equipment in there to make all of that happen. Well, it turns out that I can do all of that stuff out of the box with one of these units already. So I'm pretty impressed by that. I've been able to simulate some of these situations and really kind of explore different ways to use it in my test setup here. Hopefully it'll help you out with a project that you might be planning. I'll also tell you why I just bought another one, a second one, and I'll tell you how I plan to use that coming right up. All right, well, before we jump into running a few tests and demonstrating some of those cool operating modes, I really want to show you those. Let's quickly go through what we're working with here. It's a 6,500 watt pure sine inverter. It's designed for a 48 volt battery system. So we've got a 48 volt battery we're going to plug into it as well. And it outputs 120 volt AC, single phase AC power. You can use up to 6 of these joined together if you want to support a larger system, and even do a split phase and 3 phase. We're going to just talk about single phase right now, but I'll touch on those other options a little later. Now, since it's a hybrid inverter, we have a built-in MPPT solar charge controller. Actually, we have 2 of them. So there's 2 inputs there for 2 separate strings of solar. You know, overall, you can plug in up to, like, say, 8,000 watts of solar. Quite a bit coming in, and it's an MPPT on both of those. So I believe each one can support up to, say, 4,000 watts of solar. I'm only going to really use one of them. We can simulate some solar right now in my test setup, so we'll be able to test that. It's also a battery charger, so you can recharge your battery bank, whether it's a lithium iron phosphate battery bank like I have, or you can do lead acid, or different types of batteries. It's worth mentioning also that this is very similar to another inverter that you're probably seeing out there. It's the LV6548. The specs and everything are almost identical to this one, and the reason I went with the SUNGOLDPOWER one is I actually have another SUNGOLDPOWER inverter that's been running great. It's very reliable, so I thought I'd check out this one as well for my upcoming project. The other reason, it has to do with the solar input. The other one, I think it's the LV6548. It's got a maximum voltage input for the PV array of, I think, 250 volts. I need a little bit more than that. They're big panels. The folks at SUNGOLDPOWER just increased the rating on their MPPT controller, so it can now support up to 390 volts coming in to, I believe, each one of those 2 PV inputs. So that's going to work better for me, but otherwise I believe the inverters are very, very similar and almost identical. This one's blue though. This is the one we're testing today. Finally, the other thing to mention is that it is UL rated, so it's been independently tested here in the United States. An outfit out of California, TUV Rhineland Group. They do the UL certification. All the loads have been tested up to the specifications that are outlined here on the side of the inverter. Now keep in mind that this is just a test setup. It's not designed to support any real heavy loads at this point, just to do some basic testing and demonstration. When I actually set this up for real, we'll have appropriately sized cables and overcurrent protection devices, fuses and circuit breakers. Everything will be up to snuff. But I did want to mention that they do have some recommendations for fuses and circuit breakers and where to put them. Here's a couple diagrams I pulled from their documentation. It shows you how to set up different things and where you should put fuses, and they also recommend specific sized cable and give you the right gauges and stuff as a baseline for reference. I'm just going to set this here. There are some cables here that you have to be aware of that go to the control board and everything over here. But just going to set it just like that so we can look at the inputs in here. Well, let's start on this side here. We've got our two battery connections going in. We have our negative and our positive, and that's connected to a 48 volt lithium iron phosphate battery. Next to that we have our AC input and output. This is the output right here, and that's wired to a little outlet right here. Plugged into that I have a little space heater over here that's going to serve as our test load. Our AC single phase input is connected to an outlet here, and I have it on a switch, so I'll be able to turn it off and then turn it back on again. And over here on this far side are our two PV inputs. Now to simulate my solar here, I have a couple of power supplies hooked up in parallel, and I can generate about 100 volts coming in. Now the solar actually comes into this box here. I've got a little switch on it. I can turn it on and I can, oh, inverter's firing up. Oops. All right, we're about ready to fire this thing up and run a couple of fun tests. But before I do that, I just wanted to throw out a couple more specifications that you might want to know about. The first one is the fact that it does have a surge capacity of up to 13 kilowatts. So it's rated at 6500, but it says that it can actually handle a surge up to 13,000 watts. So 2 times what it's rated at, but only for 5 seconds. So if you do have something that really has a strong inrush current when you fire it up, it should be able to handle it for up to 5 seconds. And the second one is that it has a peak efficiency of 91%. I'm going to press this button here. It should just go right into inverter mode because there's no solar, no grid input that's turned on. So we'll just turn on this button here and fire it up. It's going to count down 5, 4, 3, 2, 1, and there we go. We've got a battery indication here showing the battery's connected, and in a second it'll kick on the inverter mode. And we got little icons here that indicate where the power is coming from and where it's flowing. Here we've got a little nice little sine wave that it's outputting right now. That's powering this, going to that outlet. And if you look at the current flowing out of the battery, we can see that it's kind of cycling between 0.3 amps and up to say 2 amps. Before we jump into the different different priority modes of this inverter, I want to first mention how it refers to these different sources and outputs. We have our utility power, and that's generally, I'm going to go to the next slide here. Utility is identified as U, so we'll see that in the settings, and solar power is S, and battery power is B. When I first was looking at the manual here, it had those S, U, and B, and I'm like, what does that mean? It took me a few minutes for that to click. When we start combining them, we can set our priority to like solar first, battery second, and utility third. And those get mixed around, so we can then have utility first, solar second, battery third. So you kind of get what we're talking about here. I'm going to run a quick test here, and just want to let you know that I am currently in solar, battery, utility, priority mode. So solar first, battery second, utility third. So it's going to try to use solar power, then it's going to try to use battery power, then it's going to try to use utility. Right now it's just connected to the battery power. I can show you here, but it'll get out of my display here. So I'll show you on the remote app right here. It's solar, battery, utility. You can see the other two options there as well, which are utility solar battery or solar utility battery. So let's try this first. I'm going to go ahead and fire up my heater. So I turn on the little space heater. I'm going to go ahead and turn on the solar input. It's going to simulate solar power coming in. And you may also notice that the color on this LED also just changed. So it's going to change colors based on the mode that you're in. And you can set what color LEDs to show in different modes too. So it's kind of a nice little setting. If we look at our little display here, it's showing a little indicator that shows that there's solar power coming in, and the power is now flowing from the solar to the load. Still got the space heater running over here. Everything's good to go. I've got solar coming in, and it's even charging my battery at the same time. Let's turn the solar off, and we'll simulate going back into just battery and inverter mode. Okay. Solar's going off. The beep tells me that I'm switching modes, and now I'm back to just inverter mode. So you can see all that right here on the screen. I've got a load, I've got battery power, and I've got the battery doing my DC to AC conversion, and then powering my load. So I'm going to turn the solar back on, and it should switch to solar power again. Okay, so now I'm running on solar. You can see here on the indicator. And you can also see this little indicator here means I'm powering by solar. Now I'm going to turn on the utility power. So let's just say now we've got grid power. It's there, but because of my priority of solar battery first, it's still powering the load from the solar. So now if we kill the solar, it should switch to just battery power. Let's do that. Okay. So it did that. It just went. I still see here on my display that I have grid power, but it's not powering the loads from that. So it's switched back to just inverter mode, which is how I'm configured, and the inverter now is powering my space heater. So everything's good to go so far. If I kill the battery, it should switch to a grid pass-through mode. So the last resort is just powering everything from the grid. Now my heater is just going to stay running this whole time. Okay, there it went. Okay, now the battery is disconnected. You can see it blinking here. Shows a little warning that says there's no battery connected. And it's powering everything right now. The heater is still running. It's switched over to grid pass-through mode. Now that could be a generator coming in, or it could be, just powering it from, a grid source. So one thing I want to mention about the solar power is that it has a minimum voltage requirement. So it won't kick on until it gets over, I think, 80 volts. So if you have a really small solar array connected to this and it's not in series, not generating enough voltage, it's not going to trigger the MPPT solar charge controller. So I'll go ahead and simulate that real quick. Let's go ahead and dial back the voltage on the solar, and I'll show you what happens. Right now we're bringing in 91 volts on solar. I'm going to go ahead and adjust that so it drops a little low. So let's just say the sun goes down and we run out of solar power. So I'm going to dial that back to 78, 72 volts. So finally it was detected by the inverter. Got my solar blinking, means that I just lost my solar power. So now it's switched back to just inverting. If I turn that back up again, 76, it should kick on just above 80. There we go. 86 volts, and the solar input kicks in and the charge controller turns on. Now let's say we want to set it up to work as a battery backup system for maybe some critical loads in your house or whatever you're using it for. We would want to set the priority to utility first. So we want the utility pass-through to be the primary, but let's just say the power goes out and the utility is gone. Then we want the secondary to be, let's say, solar. You've got some solar panels. It's going to pull whatever it can from the solar, and then the third would be battery. So then if the solar can't keep up, the battery will kick in and offset that, and it will supplement it. So it'll be utility first, solar second, battery third. So what we can do is change the setting here. We can either do it using the app, or we can do it here on the device. Let me show you how it's done on the actual inverter itself. To get into the program mode, I'm going to hold this button here, the default button, and it gets in here. I'm going to use the arrow key to go to program 1, and then from there it's set as SBU. I'm going to change it to what am I going to change to? USB. So that's what I want. And I hit that again. I'm going to turn off the battery and I'm going to reset it. So it should come up in this utility solar battery mode when it comes back online. So now the inverter is off, the battery is disconnected, and I'm going to then bring it back online. I'm going to start by turning the battery on, hit the power button here, click. It should detect that there's a battery connected. After it counts down, 4, 3, 2, 1, blast off. I've got battery power coming in. See my little indicator there, and I'm in inverter mode, so I'm inverting now. We want to simulate basically normal operation. It's going to function like a UPS. And when the grid power is available, it's going to power everything from the grid. If it falls off, it's going to try the solar and then the batteries. Turn the grid power on first. All right. The grid should come online. It's going to detect it. It should test it. Okay, now it kicked into a bypass mode, so that's what we want. So grid is on. Solar, I'll turn that on, but it shouldn't switch over to solar unless the grid goes out. Yeah. All right. So it's also kicked into a charging mode as well, and I have a different battery charging mode set up. Okay, so we have kind of a normal operation here. We're charging our battery, we're running our stuff from the grid. We've got our space heater running. Everything is good. So we're at home, all of a sudden there's a storm and the trees are blowing and we're staying warm with the heater and the power goes out. Oh, there went the power. But the lights are still on and the heater's still going because it kicked into the secondary mode, which is solar. We're pulling what we can from the solar and it's powering our loads. To simulate the sun going down, I'm going to turn the voltage down on the solar, 74 volts. Our solar just kicked out. Now we have no solar, no grid. What are we going to do? No, it's going to switch to inverter power. I've got my battery backup system powering the whole system. And the heater, it never turned off. I'm still warm, and my giant UPS solar backup power generator system is working flawlessly. Depending upon the size of my battery will determine how long I can run in this mode. So pretty cool. A few hours go by and the power comes back on. Let's see what happens. Yep, it detected the power is going to go on. It measured it, made sure everything was good, and now we're back in bypass mode and supplying power to the loads from grid power, just like we wanted. So there's a nice kind of a emergency battery backup system configuration that worked pretty well, actually. I like the way that you can switch between utility and battery and solar priorities to suit your needs. And one of the things that I'm impressed with this is that it's also using the secondary to compensate for any shortfalls of the primary. So, for example, if I'm powering from solar as a primary, we saw that if I don't have enough solar coming in and I'm using my battery as my secondary priority, then the battery is going to compensate for any shortcomings of the solar. And if I completely deplete my solar, it's just going to automatically switch to just battery or maybe even utility power. So very cool. The fans run constantly, and it's just going to constantly be cooling this inverter. So fan on either side. If you don't want that noise, in a living space or anything that it's going to bother you, you're going to have to relocate these things. I'm going to actually install it closer to our power center here in the shop, which is far away from where I'm going to be filming videos and stuff like that. So that's one thing that I noticed just having it here, is that the fans are constantly running all the time. You can also run this in purely a batteryless mode. So if you're off grid and you don't have grid power, and let's just say you have great solar power but you don't have a battery connected, you could just use your solar array to power some loads, and it doesn't even care that you don't have a battery, just as long as there's some solar power coming in. And you could probably use that together with the utility power. So let's just say you're using it to offset some loads in a situation where you do have grid power. You can set it up so that if you have solar coming in, it'll offset those loads and not take it from the grid. But if your solar drops, then the grid will take over. So you don't even need to have a battery with this system. So that's a really kind of an interesting and cool feature also. Yeah, let's talk about programming real quick. There are a ton of settings that you can adjust and program, how the inverter works, several pages of them. I'm not going to go through them all. Set alerts, voltage levels, and a whole bunch of stuff. Now you can do all of that from the front of the inverter itself. In fact, that's probably the best way to do it to start with. If you have the app set up right here, you can go into the parameter settings and set most of the major parameters through here. One thing to note is that not all of the settings are available through this app if you can get it set up and working properly. So there are going to be several things that you do have to program from the front of the inverter here. You know, the interface is kind of clunky, but it does work. Pretty good documentation. You know, I had to refer to this several times as I was kind of boning up and trying to figure out this whole inverter. Just go through all the settings and see which ones apply to your setup. One of the first things you're going to do is once you get your battery connected and everything, is to program it for the charging profile for your battery. Now it comes with a few predefined lead acid and some predefined lithium battery specs if you have the specific one that they have listed in the documentation. I went ahead and just set it to user-defined custom battery configuration and set it to the bulk and float charge settings and the cutoff voltages for my specific battery. And I got that information from the label on the battery and also from the manufacturer. Yeah, there's probably a few others in here. Let's see. AC output mode. Yeah, be sure you set the right voltage, 120 volts and 60 hertz. And make sure that it's set up for kind of single phase one inverter mode. Right now I just have the one inverter providing single phase 120 volts AC. It has the capability to chain multiple inverters together. I can start with two, so that's why I actually purchased a second one, so I can use both together to provide 240 volts. My gas generator, it actually outputs 240 volts. So what I want is actually to provide 240 volts, maybe parallel, maybe split phase. There are clear instructions in here for how to connect these communication cables that go from one inverter to the next to be able to provide the split phase or three phase or parallel modes, maybe just single phase, just parallel and multiple inverters. They've got diagrams that show you how to connect them, how to connect the communication wires that are connected under here. There's actually a hidden panel that you have to remove the outer part to get to those communication connections, and all the cables and stuff are provided. You can connect up to 6 of them in parallel to provide a lot of power for a larger system. So pretty cool that you can scale this up. Now there are also some battery charging priority modes as well. We can go solar first, so just try to charge battery from solar and utility. So what it'll do is it'll combine both solar and utility power to charge your battery. So that's another one. Or you can set it to just solar, so like only solar. Yeah, I know this is a lot of information. Trust me, I've been trying to digest all of this stuff about this inverter, understand all the different settings, and it's a bit overwhelming. So, if you're interested, I encourage you to go check out the user manual. I'll put a link to it in the video description so you can go through it, and then you can have your own mind-blowing moment like I have. One of the most appealing parts about this inverter is that it's really reasonably priced. For this guy, 6,500 watt, with all the functionality, it's about $1,300 or something right now, $1,350. Actually, because now it's around the holidays, they have a special going on, 15% off. So the one that I just purchased, the second one, I think it got it for about $1,100 or so. So pretty good deal. If there are any discounts available, I'll make sure I reference those in the description as well, so you can kind of get the best deal if you want to get one. I'll probably be making more videos in the future when I actually get to building out this system for our shop here to take it off grid, and hope you'll check in. And if you're not subscribed, make sure you do that so you can catch those in the future. And I hope this video helped you out, answered some questions for you, but I'm a bit spent, and I think I'm gonna call it quits right there. Let me know if you have any questions or comments about this, and I'll try to give you the correct answer to the best of my knowledge. So take it easy, and I'll see you in the next video.